Alright, so today we'll be looking at doing some products and quotients of complex numbers in polar form. Now back in the day before nice little graphing calculators that could actually do this pretty handily fast, they used to have to actually take complex numbers, convert them to polar form, multiply them, and then remove them back and stuff and just work with them. This was especially useful when you were working with some really complex stuff in electrical engineering. Okay, so today we'll be learning the old school way of multiplying them. Okay, alright, so let's go over first the actual rules. So the product of a complex number in polar form, so two complex numbers, r1 CIS theta 1 times r2 CIS theta 2, is equal to the product of their moduli CIS, the addition of their arguments. That's all you need to know for the product of complex numbers in polar form. Now, the quotient of complex numbers in polar form, r1 CIS theta 1 divided by r2 CIS theta 2, is you take the moduli and you divide the two, and then you take the arguments and you subtract. Make sure you keep the order correct on this one. This one up here, order doesn't matter because it's commutativity, but on this one, the commutativity does not follow towards division and subtraction, so you have to be careful. Okay, and an important formula, especially for you guys looking to go in engineering, is E equals I times Z. Now let's take a look at some problems. Alright, so let's find the product of 4 CIS 5 pi fourths times 2 CIS 2 pi thirds. So once again, we multiply the moduli, so we should get 8 CIS. Okay, then we're going to add these two together, so the common denominator would be 12. So that would be 15 pi plus 8 pi, so that would be 23 pi divided by 12. Voila, you have your formula all set up. Now, if you wanted to do a quick conversion to the actual setup of rectangular, here's what you would do. You would keep the 8 outside, okay, and you would times it by. Now we would find the cosine of 23 pi twelfths, and you could actually find that really fast. Now this isn't going to be nice and neat, but it actually sets up like this. So I could multiply the 8 by this, and you would actually get your actual measurements and everything. Okay, so you would just times 8 by this, and you would get, let me see, 8 times 0.96, so that'd be 7.68 plus, and that would be minus, so minus 0.26 times 8 would be minus 2.08 I. And so this would be the rectangular version of that. Okay, so that's some really cool stuff that you're actually able to do with the finding the products of polar forms in complex numbers. Okay. All right, now let's do some division problems with that. See how we do with it. Alright, and so what we get is this one is find the quotient of these two. So this one's going to be pretty simple. So 12 divided by 4 is going to be 3. So this is going to be 3 CIS. Now pi fourths minus 3 pi halves is going to be negative 5 pi, negative 5 pi fourths. Okay, and then you could do the same exact thing to actually convert that real fast to this, which would be negative 3 root 3 divided by 2 would be the real portion, the rectangular real. And then you would also add parentheses 3 root 3 divided by 2i. Okay, and that would be the imaginary version. So that would happen if you converted the cosine of negative 5 pi fourths. You would get negative root 3 over 2, and sine of negative 5 pi fourths would be root 3 over 2. Okay, all right. That is pretty much it for this right here. When you take a look at the actual problems, just remember that electrical engineers like to use that formula, and they like to use the form of A plus BJ instead of I, because they use I for different parts in electrical engineering. All right, that's it for the product and quotient rule of complex numbers in polar form. Thank you. Bye.